Question number 31. There is a potential difference V across a resistor of resistance R. The current in the resistor is I. Which equation gives the power P dissipated by the resistor? So there are a few formulas given. For the power, we have the normal formula, which is current times the voltage, and you have the other formula after substituting the Ohm's law. So Ohm's law is V is equal to IR. You can substitute for V using this. So it's gonna be IR. So it is I square R, another form of power. And the next one, you can substitute for the current using this, which is V over R. So I changes into V over R, and it's multiplied by V gives you V square divided by R. So the option is D. Question number 32. What is a possible charge on a particle? So this is about the quantization of charges. So it means that charge can assume only certain discrete values, and that is to say the observed value of the electric charge of a particle will be an integral multiple of E. So the total charge is always going to be NE. So that E is the charge of an electron. So N is always plus or minus 1. It could be plus or minus 2. So any discrete values, like any number. So N would be equal to Q divided by E. So you just need to divide each of the value with the charge of an electron, which is 1.6 multiplied by 10 to the power of negative 19. And using that, you will be getting each of them decimal value except the option C. So when you are dividing with this with the value of 1.6 times 10 to the power of negative 19, you will be getting 7. So that's why the option C is the correct option. Question number 33. The graphs show possible current voltage IV characteristics for a filament lamp and for a semiconductor diode. So the four options is given. Which row identifies the IV graphs for the lamp and for the diode? So the graph for each of them is shown here. For a filament lamp, this would be like a curve, and it is similar to the option P. And for the diode, it's gonna be like a curve like this. So it starts from a non-zero V value and it extends. So it corresponds to the graph of R. So the filament lamp is P and the semiconductor is R. So the correct option is option A. Question number 34. The diagram shows circuit containing a battery and cells with negligible internal resistance. Some values of current, electromotive force, EMF and resistance are shown. One resistor is labeled P. So this is the circuit. What is the resistance of resistor P? So here you have to use the Kirchhoff second law, or it is also called voltage law. Thus the sum of the EMF will be equal to the sum of the current multiplied by the resistor. So this is the normal voltage drop. So there is two loop. This is loop 1 and this is loop 2. So if you are considering for the loop 1, you can use this Kirchhoff law. So summation of the EMF, and that's gonna be 9, and it is attached from positive to positive, right? So that's why you are subtracting the other EMF value, which is 1, and that's gonna be 8, and the sum of the current multiplied by the resistor. So here the current passing through the loop 1 is given as 3 amperes. So 3 amperes is over here, and 2 amperes is passing in the loop 2. So at this junction, these two will be joining, and this across this P resistor, 5 amperes of current will be passing through it. So 5 multiplied by the resistor value which you don't know, and the next resistor is 2, and that 2 resistor is carrying only the 3 amperes of current, so 2 multiplied by 3, so it's gonna be 6 plus 5p. So therefore the sum of the EMF, which is E, should be equal to the voltage drop, that's 6 plus 5p. So 5p is gonna be equal to 8 minus 6, that's to be 2, so p is equal to 2 by 5, and that value is 0.4 ohms. So the correct option is option A. Question number 35. The diagram shows a circuit with a battery connected to a resistor R. The battery has an internal resistance represented by the resistor R. So this is the internal resistor. A second resistor identical to R is connected parallel with R. So there is an identical resistor R parallel to this resistor. Which row describes the changes to the potential difference across R and the current shown on the ammeter when the second resistor is connected? So you could see that the connection is in parallel. So in parallel connection, so one resistor and another resistor, and both of them are of R resistor. So in the parallel connection, the total resistor will be equal to 1 over R divided by 1 over R, and that's gonna be giving the total resistance to be R divided by 2. So the total resistance now is just half the before value. So R was the previous one. So for the before adding the second resistor, the total resistor was just the first resistor and the internal resistor. But now the total resistors is not only this one combination resistor but the internal resistance as well. So now after connecting the second resistor, the total resistance has increased because previously it was R plus R. Here it is R by 2 plus R. So the total resistance has decreased, which means that the current across the ammeter has increased. So the option is increase over here. And about the potential difference across R, so since the more current flows to the battery, the voltage drop across the R will increase. So the correct option is option D. Question number 36. Two identical wires X and Y, each of length L and radius R, are connected in parallel as shown. The total resistance of this combination is R1. The wire X is replaced with a wire of the same material with length L and radius 2R. The total resistance of the new combination is R2. What is the ratio of R1 divided by R2? So each of the wire is of identical. So the resistance value is rho L by A. So here, since the both wires are identical, we can keep both are having a resistance of R. So the total resistance is gonna be R by 2. After doing the formula, 1 divided by RT is equal to 1 divided by R1 plus 1 divided by R2. So here R1 and R2 will be equal to R. That's why the total combination is R by 2. So the next one, you are replacing the wire X with a different one. So it's having a radius double the previous value. So using this expression, 1 over RT is going to be 1 over Rx for the first X wire plus 1 over Ry wire, right? So what is the Rx now? It is no longer rho L by A. So here it is rho L divided by A is pi R square normally because it's of a cylindrical shape. But here the R value has doubled. So means it is 1 by 4 rho L divided by pi R square. So it is basically 1 by 4 of the previous value of R. So now how the combination would be. So now the total resistor value would be 1 divided by R by 4 plus 1 divided by the resistance R, because the Y wire has no changes. So it's gonna be 1 by 4 R times R divided by 1 by 4 R plus R. So the value is 1 by 5 R. So this is the first resistor value. This is the second total resistor. So R1 by R2 will be equal to R divided by 2 divided by R2 is 1 divided by 5R. So you can just write it like this for simplicity. R and R get cancelled, leaving 5 by 2. So this is the answer. So the correct option is option D. Question number 37. The diagram shows the currents in part of an electric circuit. So here is the circuit. The resistors are identical. So every resistor has the same magnitude of resistance. Which equation is not correct? So here you have 4 options given. So since it's about the current, you can use the Kirchhoff current law, that the total current entering a junction is equal to total current leaving the junction. So if you are considering this junction, it is I1 is the entering current and I2 and I3 are leaving current. So if you are considering this junction, it is I3 the entering one, I4 and I5 is the leaving one. So here for the first equation, you can also substitute for I3 using this. So it's gonna be I4 plus I5 in this. So these are the formulas. So if you are checking the I1, the first option, it is a correct statement, and I2, so you have to just rearrange this. So after rearranging this equation, you can get this I2 is equal to I1 minus I3. So this is also a correct option. Then option C, this one is I2 is equal to I3 plus I4. Even if you are substituting this I3 as I4 plus I5, there is a minus over here. There is no minus, so this is the wrong one. Then option D is I4 is equal to I3 minus I5. You can rearrange this one for I4, thus giving you I3 minus I5. So this is also a correct option. So the option is C. Question number 38. The diagram shows a sequence of radioactive decays involving 3 alpha particles and a beta minus particle. What is the nuclide T? So you should know the decay equations for both alpha and beta particles. So if the element is having Z and A, the proton and the nuclear number, the change happens for the daughter nuclei is the proton number changes into Z by 2 and the mass number changes into A by 4. So for the first one, it is having an alpha decay. So 93 will change into 93 minus 2, that is 91. And 237 will change into 237 minus 4, that is 233. Then for the beta decay, the proton number increases by 1 and the mass number stays the same. So here the mass number stays the same as 233, but the proton number has increased to 92. Then after the alpha decay, the proton number is subtracted by 2. So the mass number will change into 233 minus 4. So it's gonna be 229. Then after the alpha decay, the proton number changes into 88 after subtracting by 2, and the mass number changing into 229 minus 4. So it's gonna be equal to 225. So the correct option is of proton number 88 and mass number 225. So the option A. Question number 39. The number of electrons in a neutral atom of an isotope of plutonium is changed to produce a charged atom ion W and has an overall charge of plus 1.6 times 10 to the power of negative 19 coulomb. How many protons, neutrons and electrons are in W? So it's given that atom changes into an ion. So the ion is formed when that atom has lost one electron or gaining one electron. So here it is having an overall charge of plus. It means that it has lost one electron. So here for this neutral atom, the number of proton is 94 and number of electron is also going to be 94. The number of neutron is 239 minus 94. So that's gonna be 145, the number of neutrons. So after losing one of the electron, the number of electrons is changing into 93, but the proton number and the neutron number stays the same. So the option A is the correct answer. Question number 40. Which particle is a lepton? So to answer this question, you should know the classification of the fundamental particles. So basically the fundamental particles according to the interactions is classified into two: the lighter particles, leptons, and the heavy particles, hadrons. These are the leptons. So here, do you have any options? Yes, you have the option positron, and this is the lepton in this option.